Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
So in this question, a person of mass 62 kg is standing with both feet on the same step of a flight of stairs, and the height of each step is given by zero point 0.2 meter. And we have to find the gravitational potential energy of this person relative to the ground. So, in the first part of the question, we have to find the potential energy if the person is standing on the first step of the stair. So, the first step of the stair means the height of the person from the ground. Let's say this capital H is equal to the height of the first step, which is simply small h, and this is given by zero point 0.2 meter. And so the potential energy of the person will be m times g, which is acceleration due to gravity, times capital H. And acceleration due to gravity is given by 9.8 meter per second square. So the potential energy will now be 62 kg times 9.8 meter per second square times zero point 0.2 meter. And this gives the potential energy of the person at the first step to be around 121.52 joules, or we can round it up to 122 joules. The second question is similar to the first one, but here the person is standing on the second step of the stair. So the height of the person from the ground will be 2 times the height of each step. So it will be zero point 0.4 meter now. So the potential energy on step 2 will be 2 times m times, so m times g times twice of small h, which is m times g times zero point 0.4 meter, and this gives the potential energy on the second step to be around 243 joules. The calculations are really simple, so I'm not going overboard with these. So in the third part, yeah, the person is standing on the third step. So then so here the height of the person from the ground will be 3 times the height of each step. So potential energy will be mg times 3h. So when we do the calculation, so one way of making the calculations easy will be instead of multiplying the instead of finding the height capital H every time and doing this whole calculation m times g times h, you can do, we'll see that with every step this is a common factor, pe1. So if a person is standing on the second step, so mg times 2h is twice of mgh, or twice of this value. So you can simply take 2 times 121.52 and you'll find the potential energy on the second step. Similarly, the potential energy on the third step will be 3 times mgh, which is PE1. So 3 times the potential energy of the first step. So what I'm trying to say is 3 times mgh. So this mgh gives me the potential energy of the first step. So basically 3 times this value, and I get this to be, so this makes the calculations really simple and time saving. So in the fourth part of the question, we have to find the potential energy if the person is standing on the nth step, where n is some number. So as I was explaining before, the potential energy at each step is the step number times the potential energy of the first step. So we can use that concept here. So over here, then, if the person is standing on the nth step, the height will be n times the height of each step. So potential energy of nth step will be mg n times h, or n times mgh. And this is the value of the potential energy of the person when he is standing on the first step. So the potential energy of the first step is 122 joules. So PEN will be 122 times n joules. So coming to the last part of the question, we have to find the change in potential energy if the person descends from step 6 to step 2. So the initial potential energy is potential energy at step 6. So this will be 6 times mgh, because n is 6 over here. And the final potential energy is PE, potential energy when the person is standing on the second step. So this will be 2 times mgh. So the change in potential energy will be final potential energy minus initial potential energy. So it will be 2 times 6. We can factor out mgh. So this will be minus 4 times mgh, and this is like minus 4 times potential energy on the first step. And when we do that, we get, so PE1 is basically 122 joules. So we get this to be around minus 486